discuss the January 2022 P2 paper. Question number 1, they say the table below shows corresponding values of x and y for y equals 2 to the power 5 minus root x. The values of y are given to 3 decimal places. Using the trapezium rule with all the values of y in the given table, obtain an estimate for 2 to the power 5 minus root x, giving your answer 2 decimal places. Okay, so how do we get the answer 2 dp? The first thing is using the trapezium rule. We need to get the h value, the width of the strip. So how much is h? H is normally equal to b minus a over n. That's one way to get h. Or the easiest other way to get h is the gap between your x values. So how much of a gap do you have in between your x values? Actually tells us the h value. So what's the h value here? So you can see 5, 5.5, 6. So you get a gap of 0.5. The other way of doing h as 5.5 is you do b minus a. The ending x value is your b minus the starting x value is your a divided by n, the number of strips. So if you have here we have 1, 2, 3, 4, 5 columns. 5 columns means how many strips? 5 columns means there are 4 strips. So 7 minus 5 divided by 4. How much is it? 7 minus 5 is 2 divided by 4 and we get half, 0.5. So basically you could get it by using this rule, or you could just get it by observing. By taking the width of the strip directly 5 to 5.5, we have a 0.5 gap. Okay. So then using the trapezium rule, area equals half h. What do we do? Y naught is 6.792 plus 2 times the middle y values are 6.298 plus 5.858 plus 5.466 plus outside the bracket we write 5.113. Is this clear? This is the trapezium rule. So make sure you write the first part correctly and make sure you show all of this clearly. You must show this particular line of working to score the mark. Okay, you must show this particular line of working. So what do we get at the end? Type everything in the calc and I know the final answer. 11.787. Okay, so 11.79 is the final answer. Okay, correct to 2 decimal places. Is this clear? Okay, so now they are asking you to use your answer to part A and making your method clear. Estimate the integration of 2 to the power 6 minus root x, and your limits are again from 5 to 7. Okay, so look what we understand from here. Part B, Roman number 1. Now you can see we know to integrate what is the integration we found? We found the integration of what? 2 to the power 5 minus root x from the answer was what? 11.79, right? So basically by using trapezium rule, we got an estimate for the area of the curve of 2 to the power 5 minus root x between 5 to 7. Okay, but now they are saying us to use this answer and to get the answer of what? Of whom? Of 2 to the power 6 minus root x. So you can see there's a slight difference in the sum, right? The answer we found in part A was 5 minus root x, a power of 5 minus root x, while the answer we get in part B, they want us to find the area for 2 to the power 6 minus root x. So how do we work with this? Now we all know we definitely don't know how to manually integrate something like this, right? We don't know, so we definitely need to use the help of part A. So can't we make this particular equation look similar to this? You can see we have 6 here, right? Can't I break the 6 up? Because I want to see 5 here. I want to see 2 having a power of 5 minus root x, not 6. So what do we do? What do we do here? We break it up, right? How do we break it? I write here 2 to the power 6. I'm going to break it up and write as 1 plus 5 because I want to create a 5 here. 1 plus 5 minus root x. Have I done any change to the sum? Basically 6 is written as 1 plus 5. Now what do we do? If you have a number with the addition of 2 powers, do you remember what it is? A to the power x plus y means what? It means it's a to the power x multiplied by a to the power y. isn't it? So this is the rule for a to the power x plus y. So using this strategy, can't I break this 2 to the power 1 plus 5 minus root x? So we'll break it in the way we want, because I want to create the integration I have in part A. In part A, I have the integration of 2 to the power 5 minus root x. So how do I break this? I'm going to break this as integration of 2 to the power 1 times 2 to the power 5. I'm going to keep it with this minus root x. I'm going to keep it because I want to see this together. Dx. Are you with me? And now what happens? 2 to the power 1 is actually 2, which is a constant. So it can come out of the integration. You can take constants out of the integration. So 2 comes out, and inside the integral sign, you have root 2 to the power 5 minus root x. The limits are from where to where? From 5 to 7. So now is this something that's unfamiliar to us? This is the value that we found in part A. 2 to the power 5 minus root x integration from 5 to 7. Answer is already found, isn't it? 11.79. So the answer becomes now 2 times 11.79, which is how much? 23.58. So this is the answer. Try part B now. Roman number 2, they say you to find, using your answer to part A, to find the integration of 3 plus 2 to the power 5 minus root x. So in this case, you can clearly see you have this 3 is a separately addition with 2 minus 2 to the power 5 minus root x, right? So when you integrate, how does it work? You can integrate the 3 separately and the 2 to the power 5 minus root x separately. Why? Because it's an addition. So because it's addition, we integrate 3 separately from 5 to 7, and 2 to the power 5 minus root x is separately we can take from 5 to 7. So what happens when you integrate 3 with respect to x? It becomes 3x. It becomes 3x, because when you integrate a constant with respect to x, you get it with that letter. So 3x, and your integration limits are from 5 to 7 plus this one. What about the integration of 2 to the power 5 minus root x? So this integration answer is actually what we found through the trapezium rule. The integration of 2 to the power 5 minus root x is what we got, right? The area, the expression for area we got is exactly that, isn't it? So that is 11.79. So let's add everything together. 3 times x is 7 minus 3 times x is 5. Plus 11.79. So I get here 21 minus 15 plus 11.79. So how much is it? Yeah, 17.79. Okay, this is clear. Question number 2. They say in this question, you must show all stages of your working. Solutions relying entirely on calculator technology are not acceptable. So basically, you must show every stage of your working must be clearly shown. Okay, so let's do this. The curves here has equation y equal to 27 x to the power half minus x to the power 3 over 2 minus 20. Part A, find dy by dx, giving each term in simplest form. Okay, so how do we find dy by dx? Let's find dy by dx. You take the power in front, subtract 1 from the power. So I get here 27 into half times x to the power half minus 1 is minus half. Minus 3 over 2 comes front, x to the power 3 over 2 minus 1. Isn't it? 3 over 2 minus 1 is half. Minus 20, when you differentiate, it becomes 0. So now they want to give you an answer, each term in simplest form. So make sure you simplify. 27 into half is 27 over 2 x to the power minus half. And then minus 3 over 2 x to the power plus half. So this can be considered as a final answer. Okay. Then let's move on to part B. Hence, find the coordinates of the stationary point of C. So what happens at the stationary point? At stationary point, dy by dx equals to 0. So I get here 27 over 2x to the power minus half minus 3 over 2x to the power half equals 0. So we need to make x a subject here. So 27 over 2x to the power minus half. Take the minus 3 over 2x to the power half to the other side as a plus. Plus 3 over 2x to the power half. The next thing is, I prefer to take all my x terms to one side, and you can see here I have x to the power minus half. How do I fix that? 27 over 2 times x to the power minus half comes down as x to the power plus half. Then I get here 27 over 2 into 3 over 2 times x to the power half. I'll take this x to the power half to the other side as into x to the power half. Are you with me? This x to the power half, I took it to the other side as a multiplication. So I end up getting here 27 over 2 into 2 over 3. Right? I took the 2 here up as a multiplication. 3 came down as a division. I'm trying to make x the subject. X to the power half into x to the power half gives me x to the power 1. So basically x is equal to the 2 and 2 cancels. I get here 27 over 3 means x equals to 9. That clear? X equals to 9. So they want us to find what? Find the coordinate. So coordinate is not just finding x, but you must also find y. How do we find y? Input the x value into the y equation. So substitute the value into the equation, y equal 27x to the power half minus x to the power 3 over 2 minus 20, right? So let's input the value. Y equals 27 times 9 to the power half minus 9 to the power 3 over 2 minus 20. How much is y? Type. Okay, so this you can type in your cal and get the answer. This is 34. So basically the coordinates. So find the coordinates of the stationary point of C. The coordinates are 9, 34. Then moving on to the next part. They say find d square y by dx square and hence determine the nature of the stationary point. So they're asking you to find the nature of the stationary point by getting d square y by dx square. So I'll do part C at this over here. Part C. So we found dy by dx. They ask you to find d square y by dx square, which means what? Which means you need to differentiate your dy by dx another time, once more. Okay. So let's differentiate. D square y by dx square equals 27 over 2 into x to the power minus half. When you differentiate, it's minus half. X to the power minus half minus 1 is minus 3 over 2. Minus 3 over 2 times x to the power half. You bring the half in front. Half times x to the power half minus 1 is minus half. Is it clear? So I get here minus 27 over 4. X to the power minus 3 over 2 minus 3 over 4 x to the power minus half. Is this clear? And now what do we do? They're asking us to verify. They're asking us to verify whether the turning point, stationary point is a maximum or a minimum. What do we do? Input the x value. So when you input the x value, d square y by dx square equals minus 27 over 4 times 9 to the power minus 3 over 2 minus 3 over 4 times 9 to the power minus half. What's the d square y by dx square value? We get minus half, which is what? Less than 0. Thereby, what do we realize? The stationary point is a maximum. You can say here, yeah. You can say like this, d square y by dx square is negative, therefore maximum. Is this clear? Okay. So now we'll move on to question number 3. They say here, find the first 4 terms in ascending powers of x of the binomial expansion 2 minus kx over 4 to the power 8. Okay, so how do we expand this binomially? What do we do here normally? So how does the binomial expansion work? Now they say here in ascending powers of x, right? Which means x powers need to go in x powers need to go 0, 1, 2, 3. So let's start here 2 minus kx over 4 to the power 8. So how do we start this? So we go with 8c0, isn't it? That's how we get the coefficients, right? So we start with 8c0 and then for 2 we will give the power what? Because our 2 terms are 2 and minus kx over 4. Since I want my x terms to be in ascending powers, I will give 2 to the power 8 and the other one is minus kx over 4 will get the power 0 because x needs to have the power 0. Now how many terms do we need? We need the first 4 terms. So this is the first term. Get the next term. Plus 8c1 2 to the power 7 times minus kx over 4 to the power 1. Do you see this? Here the power is 8 minus 1. Here the power is 1. The next one, 8c2, 2 to the power 8 minus 2 is 6 into minus kx over 4 to the power 2. So you agree? So I have written 1, 2, 3 terms. 3 terms. Now the next term will be the last one, the fourth term. Fourth term is 8c3, 2 to the power 8 minus 3 is 5 into minus kx over 4 to the power 3. Okay, so then they ask us to give the answer in the simplest form, right? So this is the expansion. Then they say give each term in its simplest form. So what do you mean by simplest form? Simplify as much as possible. So how do we simplify as much as possible? Minus kx over 4 to the power 0. Any number to the power of 0 is 1. Okay, so simplify how much is 8c0? Get the cal. Let's type 8c0 is 1, right? 8c0 is 1. 2 to the power 8 is 256. So 1 times 256 gives me 256. Okay, so the other guy, just take the cal and we'll start typing. So this one, the next one is 8c1 into 2 to the power 7. And then minus kx over 4 will have to give it manually. So I can take a 1 over 4 out here, isn't it? You say I can take into minus 1 over 4. Do you see from the bracket? Because I can't give k and x, I'll give minus 1 over 4. And then I'll get the coefficient minus 256. And what's the letter? Kx. Minus 256 kx. Okay, let's go for the next one. So the next one, take the cal. So we'll go with 8c2 times 2 to the power 6. 8c2 times 2 to the power 6 times. So here be careful. I gave a bracket here because it's minus 1 over 4. What is it? Minus 1 over 4. This time there's a square. So can you see the way I'm typing it in the cal? Be careful about the way you type. Okay. So we can't give the k and x, we'll give minus 1 on top over 4, whole thing square. Is this clear? So what do we get here? 112. 112 and what's the letter here? The letter value is k square x square. Okay, 112 k square x square. Okay, and then the next one, the last term. Let's find it. 8c3 into 2 to the power 5 into again bracket minus 1 over 4 whole thing to the power 3. You see the way I typed it, the way I gave it in the cal. So I get here minus 28 and what's the letter power? K cube x cube. So this is the expansion of the first 4 terms in ascending powers of x and each term is now given in its simplest form. Is that clear? Part B, they say in the expansion of fx, the constant term is 3 times the coefficient of x. Find the value of k. Okay, so first what we need to do here is, let's write this up. So what do we get here in part B? Fx is equal to 5 minus 3x multiplied by 2 minus kx over 4 to the power 8. Basically, 2 minus kx over 4 to the power 8 is what we expanded in part A, isn't it? So I can use that answer over here. So this multiplied by 256 minus 256 kx plus 112 k square x square minus 28 k cube x cube. Okay, so then let's open the bracket. Now, I mean, what term do we need here? Basically, you don't need to open the bracket and write everything here. It's not necessary. Okay, so what you need to do here is just get the, what coefficients do we need? The constant term is 3 times the coefficient of x. Basically, get all the constant terms and get all the x terms. That's it. You don't need to open the bracket and get everyone involved. Okay, so what are the constant terms we can get here? Just get only the constant terms and the x terms. We don't need to open up everyone. So 5 times 256. Can I have the answer? What's 5 times 256? That's a constant term, right? How much? 1280. That's a constant term. So I'll be writing it. And then the next term, 5 times minus 256 kx. That's a x term. So I will definitely get that. Tell me the multiplication 5 multiplied by minus 256. How much is it? 5 multiplied by 2 minus 256 is minus 1280. And what are the letters? Minus 1280 kx. Don't forget the letters. There's kx here. Okay, and then do I need to go with the other terms? Now I multiplied this guy. Do I need to go 5 times 112 k square x square? No, we don't need to because we are only bothered here about the x terms and the constant terms. So anyone who gives us powers of x square, x cube, or anything else, we really don't need to take them. So I don't need this guy. Do I need 5 times 28k cube x cube? No. Okay, so that's done. Now let's move with 3x. So 3x times 256, what does it give us? Minus 3x actually. Minus 3 times 256. How much is it? How much? Minus 768. What is it? X. Don't forget the x here. Minus 768x. Do I need to continue doing this? Minus 3x into minus 256 kx, right? So x and kx is kx squared. Do I need to go with kx squared? No. So basically, you can see that's it that I can take. Those are the x terms and constant terms I can take. So that's it now. Now, what's our constant term? The constant term is 1280. And what's the coefficient of the x term? Just take the x term. What's the coefficient? Minus 1280k minus 768. Okay, I remove the x term. I mean, basically, it's like I take x out and I'm taking what's remaining inside. Minus 1280k minus 768. Okay, when you take x out, basically the coefficient of x. Okay, x term coefficient and the constant coefficient. Now, what do they say here? They say the constant is what? The constant is 3 times. So 3 times the coefficient of x. Do you see the way I built my equation? So the constant is the equal mark 3 times the coefficient of x. So constant is 1280 equals 3 times the coefficient of x is minus 1280k minus 768. And now what do we do? Solve this equation and make k the subject. Okay, let's make k the subject. Is 1280 divisible by 3? No. We'll multiply with 3. 3 times 1280 is how much? Minus 3840k. Don't forget the k. And then 3 times minus 768. 3 times minus 768 is minus 2304. Are you with me? So I'll take the I'll take this guy here and I'll take this over here. I want to make my k term positive. 3840k equals minus 2304 is over here in this side, and I'll take 1280 to the other side as minus 1280. The 1280 goes as minus. Okay, so we'll add these two. Minus 2304 minus 1280 minus 3584, and here I get 3840k, making k the subject. Minus 3584 divided by 3840 gives me minus 14 over 15. So basically this is your answer. Question number 4. Using the laws of logarithms, solve logarithm of 32 minus 12x to the base 3 equals 2 times logarithm of 1 minus x to the base 3 plus 3. Okay. So how do we solve logarithms? So mainly one of the easiest techniques that we do is we normally take logarithms to one side. That's one thing we could do here. We can take both the log terms to one side. So what do I get here when I take the log terms to one side? Log base 3, 32 minus 12x here. I can take this to the other side as a negative. Minus 2 log base 3, 1 minus x equals to what? Equals to 3. Do you agree with me? I took the 3 here and took this to the other side. Are you with me? Okay, now what we do is log base 3. By the way, now here we can see in between the logarithms there's a subtraction. But a subtraction, normally in between logarithms, when there's a subtraction, if you have log A minus log B, we can write it as a division under a single logarithm, right? We can write it as a division under a single logarithm. However, you can see here outside we have a 2. So this 2, we cannot do the division while this 2 is the outside. So I'll bring this 2 inside. What do we have here? Log base 3, 32 minus 12x minus log base 3, 1 minus x. What happens to the 2? I'll take it in as a power. Equals to 3. Okay, so then we get here log base 3. So now I can take it as a division, right? 32 minus 12x over 1 minus x square equals to 3. Do you agree with what I did here? It's a division. Okay, so now what do we do? The next step, after you come to this point, what do we do? How do we get rid of the logarithm? How do we get rid of the log here? What we do is we convert the log form to, you remember? When you have something like this, if you have logarithm of c to the base a equals b, we can convert it to index form by writing a to the power of b equals to c. This is the index form. The log form can be converted to index form, a to the power of this b equals to c. And then you can get rid of the log. So basically here, I can use that same rule over here. What do I get then? 3 to the power of 3 equals 32 minus 12x over 1 minus x square. Are you with me? So what do I get here? 3 to the power 3 is 27. 32 minus 12x over 1 minus x square. You can expand 1 minus x square, right? 1 minus x square is 1 minus x into 1 minus x. Okay, so let's get the answer. Simplify, open the bracket, take it to the other side together. So I get here 27 equals 32 minus 12x. Are you capable of opening 1 minus x into 1 minus x immediately? You could, of course, take 1 minus x square to the other side as a multiplication and then expand the bracket also. There's no problem with it. Okay. So I get here 1 minus x into 1 minus x is 1 into 1 is 1. 1 into minus x is minus x. Minus x into 1 is minus x. Minus x into minus x is plus x square. Are you with me? Shall we take this to the other side? It goes as a multiplication. So I get here 27 times 1 minus minus x gives us minus 2x plus x square. Do you agree with my working? Equals on the other side I have 32 minus 12x. Minus x is minus 2x plus x square equals 32 minus 12x. So now let's say open the bracket. I get here 27 into 1 is 27 minus 27 times 2 is 54 plus 27x square equals 32 minus 12x. Are you with me? Taking everything to one side, I think you can see we get a quadratic equation. So minus 54x and taking the minus 12x as plus 12x. Can I have the value here? Minus 54 plus 12 is minus 42 minus 42x. And what about the constant? 27 minus 32 is minus 5 equals 0. Okay, so I get a quadratic equation now. Solve this quadratic equation. What are the two factors? 3x minus 5 is one factor. The other one is 9x plus 1 equals 0. Right, so you can factorize this and make sure that you get the 3 times 9, we get the 27 extra clearly here, right? So you see, make sure the factorization is correct so that you will not lose method marks, okay? And then you get 2x values. So 3x minus 5 equals 0, and you get 3x equals 5, thereby x equals 5 over 3, or 9x plus 1 equals 0, thereby x equals minus 1 over 9. Shall I write it immediately? So we get two answers. However, even though you get two answers, now many of you would finish the sum at this point. But it is not actually over. It's not actually over because you need to actually go take these two x values, go back to your sum, and there's a certain rule in logarithm. The rule is now say you take your calculator and let's say we type here log base 3, basically any logarithm. So I'll give here log base 3 and if your inside of the logarithm is a negative figure, anything, negative 5, just give negative 5, you can give any negative figure you want. You will always get what? You will always get math error. Do you see? As long as it's negative, it's math error. If I make it just positive, I get an answer. But if I make the inside of the logarithm negative, can you see I get math error? Okay, so the rule is whatever the x value that you get should not make the inside of the logarithm negative. If it makes it negative, then it's not actually a solution. It's just a solution of this quadratic equation. But being a solution of the quadratic equation doesn't mean it's a solution for this logarithm equation, because we are trying to solve the logarithm problem. Our main problem is the logarithm problem. The quadratic equation was created in the process of it. So getting answers for the quadratic doesn't mean that it's the answer for the logarithm if it makes the inside of our logarithm negative. Okay, so shall we check on the two values? X equals 5 over 3. Can you check on it? When x equals 5 over 3, check whether 32 minus 12x becomes negative. 32 minus 12x. I'll give here like this. 32 minus 12x. What was our first x value? Calc x value was 5 over 3, right? So when I give x is 5 over 3, I get a positive answer. That's okay, right? What's the other answer? Minus 1 over 9. Calc, I'll give minus 1 over 9. Okay, so that means 32 minus 12x logarithm is okay with both the values. Shall we check the other side? It needs to work for the other side as well. Okay, so for both the logarithms, log 32 minus 12x and log 1 minus x. So when we go to log 1 minus x, actually the log 1 minus x is what's going to give us the problem here. I'll explain you why in a moment. So 1 minus x, calc, when I give x is, what was our first figure? 5 over 3, right? Do you see what I get here? The inside of the logarithm of 1 minus x when x is 5 over 3 is a negative figure. So basically if x is 5 over 3, this particular logarithm becomes negative. Okay, and then the other answer is not a problem, right? Let's check that also. We'll check x is minus 1 over 9. What do we get? We get a positive figure. Do you see what I'm talking about? So basically the problem comes here because, we take this 2 inside as a power, right? As a square. So when you take it inside as a square, that's why, that is the main reason why. Okay, so basically I substituted x is 5 over 3 to 1 minus x and we got a negative answer, right? That was where what we were discussing. So minus answer. And the other guy, so thereby you need to realize that 5 over 3 is not suitable because it makes the inside of our logarithm negative. So just check with the minus 1 over 9 as well and confirm. Minus 1 over 9 gives us a positive answer, which means minus 1 over 9, x equal minus 1 over 9 is the value of the x value that satisfies both the logarithms, keeping it positive and also satisfying this particular equation. So your final answer, you must give it as x equal minus 1 over 9 is the final answer. Is that clear? So make sure you give your final answer clearly, and you need to discard this particular person. You need to cross it out. This is not the answer. Is that clear? Okay, moving on to question number 5. They say fx equals 3x cubed plus ax square plus bx minus 10, where a and b are integers. Given that when fx is divided by x minus 1, the remainder is k. When fx is divided by x plus 1, the remainder is minus 10k. And k, they have given k is a constant. Show that 11a plus 9b equals 83. Okay, so what's the remainder theorem? So you have learned this theory in P2, right? P2 chapter 1 or chapter 2, right? Okay, so anyway, fx equals, so if you are dividing by x minus 1, what do we replace x with? X minus 1 means we replace x with 1. If you have x minus 1, we replace x with 1 and we say f1. f1 is equal to what? The value when you replace x with 1 into this equation, you end up getting the remainder. So what's our remainder? The remainder is k. So this is the first equation. F1 equals k. So what about the next equation I can create? When you divide by x plus 1 means what's the x value we need to use here? For x plus 1, the x value we will use here is minus 1 because it's x plus 1. If it's x plus 1, it should be like you make the bracket basically equal to 0. X plus 1 equals 0 means x is minus 1. Do you get it? So then in the other one, it's f minus 1 equals to what? What's the remainder? Minus 10k. Are you with me? Shall we create the two equations now? F1. Shall I write the two equations on the side? F minus 1 equals 10k. Let's create the two equations. F1. Let's create the first equation. F1 means what? Replace all your x values with 1. What do we get here? 3 into 1 cube plus a into 1 square plus b into 1 minus 10 equals to k. Are you with me? 3 into 1 cube is 3 plus a into 1 square is a plus b into 1 is b minus 10 equals k. Do you agree with me? So simplified, I'll keep the we'll keep the terms in one side. We have the k term here as well, right? So get the answer here. We need to get rid of the k basically, right? So what I'll do is I'll keep here in terms of k. We need to get rid of the k and get this equation. Let me simplify it a little bit further. A plus b plus 3 minus 10 is minus 7 equals to k. Are you with me? Get the other equation. F minus 1 is 3 times minus 1 to the power 3 plus a times minus 1 to the power 2 plus b times minus 1 minus 10. Do you see what I did here? I replace all the x values with minus 1. Minus 10 equals to is equal 10k. Is equal 10k. So let's simplify. Minus 1 cube is how much? 3 into minus 1 cube is minus 3. Are you with me? A into minus 1 square, minus 1 square, it's a plus. So plus A.
Teacher,
B into minus 1 is minus B, right? Yeah, this is supposed to be minus 10k. Yes, the remainder is minus 10k. Can you see? Yeah, this is the remainder is minus 10k. Yes. So minus 3 plus A. Then this is minus b minus 10 equals to minus 10k. Is that clear? When I simplify here, I get a minus b minus 3 minus 10 is minus 13 equals to minus 10k. Are you all with me? So I have got the two equations. Now what we could do is we could, if you want, we can equate, like we can substitute. Now I have here the substitution for k. K is a plus b minus 7. We can directly put that k value over here. Can you see? Or else if you want, we can even divide the two equations and k will cancel out. Basically anything is fine. Okay, there are many techniques. You could divide and then the k's will cancel if you divide. Or else you could substitute. Shall I substitute? When I substitute to equation 2, I get here, I'll use this equation. A minus b minus 13 equals minus 10 times, what's the k value? A plus b minus 7. Can you see what I did here? The k value is entirely substituted. This entire k value was substituted over here into this k. You see? So now when we expand the bracket, we must be able to get the show that. Let's work on it. A minus b minus 13 minus 10 into a is minus 10a, minus 10 into b is minus 10b, minus 10 into minus 7 is plus 70. So take the 10a here, minus 10a comes as plus 10a, Plus 1a is plus 11a. Plus 10b minus 1b is, how much is it? Plus 9b, right? Plus 10 minus 1 is plus 9b. I think the question was they've taken the 13 to the other side. So it's going to be on the other side, 70 plus 13. 70 plus 13. So 11a plus 9b, 70 plus 13 gives us plus 83. Is this to show that? 11a plus 9b equals 83. So it's to show that, showing, I know that you prefer to write with some steps, you prefer to write, a lesser number of steps, but in show that it's better that you show some working to get the full method marks, okay? Moving on to part B, given also that 3x minus 2 is a factor of fx, find the value of a and the value of b. Okay, so if 3x minus 2 is a factor, what does it mean? A factor means what? It divides your fx perfectly. It divides your fx perfectly means the remainder is, it divides your fx perfectly means your remainder is equal to what? Your remainder is equal to 0. Okay, so basically when 3x minus 2 means what's the x value I use? So make 3x minus 2 equals 0. What do we get? 3x equals 2, thereby x equals 2 over 3. Are you with me? X equals 2 over 3. So what do we do here now? We take our fx and replace the x with 2 over 3. Take your equation, replace the x with 2 over 3. Are you with me? Replace all the x's with 2 over 3 and make the answer equal to 0 because they say 3x minus 2 is a factor. Okay, so well, let's input the value. 3 times x cube. X cube is 2 over 3 to the power 3. A times x square. 2 over 3 to the power 2. Plus b times x is 2 over 3 minus 10. Are you with me? I replaced all the x values here with 2 over 3. So this is equal to what? This is equal to 0. Why? Because 3x minus 2 is a factor. Basically, when x equal to 2 over 3, the remainder must be equal to 0. Solve this equation and you will get another equation with a and b. That equation you must solve it simultaneously with the top equation and get the answer for a and b. Are you with me? So let's quickly do it. What's the answer here? 3 into 2 over 3 cube. Can I have the answer? 3 into 2 over 3 to the power 3. 8 over 9. A into 2 over 3 square. Basically, 4 over 9 A. Then B into 2 over 3 is plus 2 over 3 and that's B. Minus 10 equals 0. So then when you take this equation, you can see we get a lot of fractions and I don't want to work with fractions. I'll take the whole equation, multiply. What's the best value to multiply the whole thing with? Let's multiply the whole thing with 9. Multiply the whole thing with 9. Okay. Okay, so then let's multiply. I get here 8 plus 4a. 2b over 3 into 9 is the 3 and 3. We get here 2 times 3, right? Which is 6b. 2 over 3 into 9 is 6. Minus 10 into 9 is 90 equals 0. So let's make a and b together. 4a plus 6b minus 90 plus 8 is minus 82. Taking to the other side, I get plus 82. Is that okay? Shall we simplify the whole equation? We could maybe divide by a 2. What do we get? 2a plus 3b equals 82 divided by 2 is 41. Are you with me? Is this okay? Okay, so now it's a pair of simultaneous equation. This equation you have to solve it with 11a plus 9b equal 83. So I think you can do this in the traditional way where you can, make the coefficients equal and or else you can do substitution. Okay, so you need to solve the two equations simultaneously and get the answer. So shall I just multiply the whole equation with 3? Why am I multiplying it with 3? Because I can see here 3 times 3, 9b and I get 9b here. Okay. So I get here 3 times 2 is 6a, 3 times 3, 9b, 3 times 41 is 123. Are you okay with that? Okay, so now let's take the equation. 6a plus 9b equal 123 from here. The top equation was 11a plus 9b equals 83. So we'll take these two equations and what should we do? We will subtract them. We will subtract because when we subtract, the 9b will cancel out. Okay, so I'm going to do this in the easy way. So 6a minus 11a is how much? 6a minus 11a is minus 5a, isn't it? Then 9b minus 9b is 0. That's the whole point. We are doing this so that b will cancel. Next one, 123 minus 83. Subtract, get rid of one variable. In 123 minus 83 is 40. So basically minus 5a equals 40. A equals 40 divided by minus 5. Isn't it? 40 multiplied by minus 5 times a. So times goes as a division. 40 divided by minus 5 is minus 8. And then replace the a value into any one of the two equations. Get b. So substitute the a value. 6a plus 9b equal 1, 2, 3. 6 times minus 8. Plus 9b. So how much is 6 times minus 8 is minus 48. Plus 9b equal 1, 2, 3. How much do I get for 9b? 48. When we add with 123, what do I get? Minus 48 goes to the set as addition. So 123 plus 48, which is 123 plus 48 is 171. Now divide 171 by 9. What do we get? 171 divided by 9 is 19. So this is your a and b value. Is that clear? Okay, so then we found our a and b values. Now let's move on to part C. Hence, find the quadratic expression gx such that fx equals 3x minus 2 times gx. Okay, how do we get this one? Basically, we know that 3x minus 2 is a factor, right? 3x minus 2 is a factor of fx. Thereby, what do we need to do here? Our fx, we should divide by 3x minus 2 because 3x minus 2 is a factor. So 3x minus 2 along with another fx is a cubic factor. Thereby, 3x minus 2 multiplied with another quadratic. Gx should be a quadratic term because a quadratic term multiplied with the x term only should give you x cube. Okay, so how to get the remaining, the quadratic term here for gx? Yeah, fx term, you will divide. You see here, the 3x minus 2 can go as a division. So fx, if you divide by 3x minus 2, you can get the gx. Do you understand? So we'll do the long division here. 3x cube, a was how much? A was minus 8, right? Minus 8x square. B was plus 19x minus 10. This is our fx term, replacing a, b values. Now let's divide this by 3x minus 2. Do long division. To divide by 3x minus 2. So 3x cube divide by 3x. 3 and 3 cancels. I get here x square. So I'll put x square up over here. Multiply. X square into 3x is 3x cube. X square into minus 2 is minus 2x square. Subtract. So what do we get here? 3x cube minus 3x cube is 0. Minus 8 minus minus 2 is, yeah, minus 8 plus 2, basically minus 6x square. And you can bring the other two terms down as well, minus 19x minus 10, okay? Then what do we do? Minus 6x square, we will divide by 3x. So when I divide by 3x, what happens? X to x cancels. Minus 6 divided by 3 is minus 2 and there's x remaining. Are you with me? So I'll write the minus 2x. Now what do we do? Take the minus 2x and multiply minus 2x with the 3x minus 2. Is that okay? So multiply minus 2x into 3x is minus 6x square. Minus 2x into minus 2 is plus 4x. So again, time to subtract. So minus 6x square minus minus 6x square, that is minus 6 plus 6 is 0. Plus 19 minus 4 is 19 minus 4 is 15x, and then you have the minus 10. There's nothing to subtract with minus 10. Then 15x, what do we do now? Again, the 15x we will divide with what? 15x we will again divide with the 3x. This is how we do the long division. X and x cancels. 15 divided by 3 is 5 plus 5. So now it's again time to multiply. So how do we multiply? Plus 5 times 3x is 15x. Plus 5 into minus 2 is minus 10. So when we subtract, we get 0. Do you see 15 minus 15, 0, minus 10 minus is plus 10. That's 0. So basically you can see we got a perfect answer. Because 3x minus 2 is a factor, you must expect to see a perfect division at the end. Are you with me? So then I have my gx over here. Who is gx? So basically they're asking us to express fx. So fx equals 3x minus 2 times gx is x square minus 2x plus 5. Is that clear? Okay, moving on to question number 6. They say here the points P, Q, and R lie on the circle C as shown in figure 1. Show that angle PQR is equal to 90. How do we show that angle PQR is equal to 90? What's the strategy you would use here? They've just given you 2 marks. So we need to find some easy technique to show that it's becoming 90. Basically, at the angle Q, it's going to be a 90. How do I prove at angle Q there's a 90? What's the technique of proving there's a 90 at angle Q? Yeah, what do we do here? We go to the product of the gradients. Are you aware that when there is a perpendicular, the gradient product is equal to -1? So what I do here is I'll get the gradient of RQ and I'll get the gradient of PQ. So gradient of RQ is y1 minus y2, or basically should I directly use minus 30 minus minus 26. So y1 minus y2 over x1 minus x2. So how much do we get for the gradient of RQ? Get me the answer. Can I have the simplified answer quickly? Minus 30 minus minus 26 over 15 minus minus 7 is, yeah, minus 2 over 11. Get the gradient of PQ. Y1 minus y2, 14 minus minus 30 over 23 minus 15. How much is the gradient of PQ? 14 plus 30 over 23 minus 15. 11 over 2. Now multiply gradient of RQ multiply by gradient of PQ gives me minus 2 over 11 into 11 over 2, which gives me what? Minus 1. Thereby, what do we realize? Therefore, PQR equals to 90 degrees. Is this clear? Let's move to the next part. Hence or otherwise, find the center. How do I find the center? How do I find the center? Okay, how do we find the center here? Now you do realize that the RQP is a 90 degree here, right? So if there's a 90 degree, we say, what's the circle theorem we use here? Angle in a semicircle is a right angle. What does it mean basically? RP is your diameter. So that's the most important thing to figure out. RP is the diameter. So if RP is the diameter, how do you get the center? To find the center, you can get the midpoint of the point R and P. If you get the midpoint of R and P, you immediately get the center because RP is the diameter. Is that clear? So get the answer here. Center coordinates. They've just given like a few amount. I mean, it's not much. So we can get the answer directly. So we'll add the coordinates and divide by 2. Add the x coordinates 23 and minus 7. 23 you add with minus 7, divide by 2. The other one 14 you add with minus 26 and divide by 2. How much is the center? 23 and minus 1 when you add? 23 and minus 7. We divide by 2, we get 8. Yeah, and then 14 minus 26, we add and divide by 2, we get minus 6. So your center coordinates are 8, minus 6. Roman number 2, get the radius. How do we get the radius? So we had used the distance equation. Radius distance equation, you could use the distance from the center. So you got the center now as 8, minus 6. So you can get the distance from the center C to point P, or from center C to point Q, or from center C to point R. Anything. Get the distance. x1 minus x2 square plus y1 minus y2 square root. Okay, I'm going to get the distance directly from the center. If you get PR distance, then you should divide by 2. Okay, so if I go from O to P, then I don't need to divide by 2. I immediately get the radius. Find the answer. So then we get here for radius, shall I use O and P? So I get here 23 minus 8 square. So go in the order that you selected. I went in PO order. 23 minus 8 square plus 14 minus 6 square root. How much do I get here? I'm getting the distance from O to P. So I don't need to divide it by 2. Okay, so what is the answer we get here? Can I know the answer? Root 625, which means 25. Okay. Next one. Given that the point S lies on C such that distance QS is greatest. Okay. So distance, they say given that point S lies on C such that distance QS is greatest, find an equation of the tangent to the curve at S giving you answer in this form. Okay. So first thing you have to do is you have to locate the point S here. Now what do they say here? QS distance is the greatest. Now point Q, you can see they have marked at this over here. So first of all, how do we find the coordinates of point S? From Q, now they say S is also a point on the circle, right? S also lies on C. So where do you mark this point S so that it's the greatest distance from point Q? At which point? Where should I mark S? Can I mark S randomly like this over here? Is this the shortest? Is this the greatest distance from Q to S? No, right? I think you can see if I mark these points, these are getting greater and greater. So I need to get the greatest distance from Q to S. Where do you think is the greatest distance from Q? Where do you think is the greatest distance from Q? Now I want another point on this. Okay, so shall I erase these other lines? Okay, let me erase these other lines. So this is point Q. I want another point called S, which is situated at the greatest distance away from Q, but it lies on the circle. So where do you think that point S will be? Okay, so basically if you draw, it's like Q is the start of your chord and like S is the end. So like basically, what is the chord where we can make Q as the longest? So what is the normal, the longest chord in a circle? So this is something you have learned in your O levels as well. What is the longest chord that you draw in a circle? The longest chord that you draw in a circle is its diameter. So basically, if you want the furthest distance away from Q, you need to consider what? The diameter. Okay, so to get the diameter. So basically the diameter. So this is the point S. Okay, so it passes through the center of the circle. Something like this is point S. Okay, I'm just roughly estimating and drawing it. Okay, so how do I find the coordinates of point S? So this is the diameter. Basically, it goes through the center of the circle. What was the center of our circle? 8, minus 6, right? This was the center of the circle. So can't I find the coordinates of S now? Can't we find the coordinates of S? We can, right? How do you find the coordinates of S? By using the midpoint. So when we add the two coordinates, the two corner coordinates and divide by 2, I get the center coordinates. So what is it? Coordinates of point S. How do I find it? X plus X I have to add with what? X plus 15. Add and divide by 2, you get the middle value, which is 8. And then I get here X plus 15 equals 2 times 8 is 16. So X equals 16 minus 1 is 16 minus 15 is 1. Is that okay? And then get the Y coordinate of S. So Y coordinate is Y, we have to add with the minus 30 and divide by 2. Add the two corner coordinates and divide by 2 and you get the center coordinate, which is minus 6. So Y plus minus is minus. 2 into minus 6 is minus 12. Y equals minus 12 plus 30. So y equals how much? How much is it? 18. Y equals 18. So your point is coordinate is 1, 18. Are you clear with that? Okay, so now what do we need to do? They are asking you find an equation of the tangent to the circle at S. Find an equation of the tangent to the circle at S, giving you answer in the form ax plus by plus c equals 0. So they want you to find the tangent to the circle at the point S. How can I find the tangent here? What is the theory behind find the tangent? What do we know about the tangent? We know tangent is perpendicular to what? Tangent is perpendicular to the radius of the circle. We say tangent and radius are perpendicular, isn't it? So do you see here CS is a radius and tangent. So basically, how do we get the equation of the tangent? Now, if you want the equation of the tangent, you know, it's a straight line. We need the gradient and we need a coordinate, right? Y minus y1 equal gradient x minus x1. So I have a coordinate on this tangent already. The only thing that I'm missing is the gradient. How do I get the gradient of the tangent? We can't do dy by dx. We don't know the equation. Normally, to find the gradient of the curve, we get dy by dx, but that doesn't work here. So what can we do here? We can get the gradient of the radius and do gradient product and get the radius of the. Actually, we don't need to get the radius. I mean, the QS gradient is already found, isn't it? Are you with me? Do I need to specifically find the CS gradient again? No, because we already found the gradient. The SQ gradient was found in. We found it, right? No, it's not found. I'm sorry. It's not found. We found previously the RQ gradient and we found the PQ gradient. No, we did not find SQ. So I will have to go. Shall we find the SC gradient? The radius, the gradient of the radius. Get it? Gradient of radius. What is it? Y difference. 18 minus 6 over x difference is 1 minus 8. Are you following me? Y difference over x difference. How much is the answer? How much is the answer? Get me the answer. Minus 24 over 7. So if that's the gradient of SC, then what's the gradient of tangent? You know, now tangent and radius are normal, are perpendicular. So a gradient of your tangent will be what? You have to take the reciprocal, right? So take the reciprocal and change the sign. So basically plus 7 over 24. Gradient product is minus 1. Do you agree with me? The easiest way to do it is we can switch the, we can take the reciprocal of the fraction and switch the sign. So now my gradient of tangent is there, which means here the gradient value is 7 over 24. Do you agree with me? So now I can use y minus y1 equals gradient x minus x1. This gives me the equation of the tangent. Y minus y1 is 18. Gradient is 7 over 24 times. X minus x1 is 1. Have they told us any particular form? Yes, they have told us given the form ax plus by plus c equals 0, where a, b, c are integers to be found. Shall we move 24 to the other side? Multiply y into 24 is 24y. 18 times 24 is minus 432, and open the bracket here with 7. The 24 is gone. Now you open the bracket with 7. I get 7x minus 7 into 1 is minus 7. So I get here 24y minus 7x, and I get here minus 432. I'll take the minus 7 to this side as plus 7. And I get minus 425. Is that okay? Yeah, so this is the equation. If we keep our x positive, there's no need. We can keep this as a final answer. There's no problem. Okay, so else you can give plus 7x minus 24y plus 425 equals 0. Even if you keep your final answer at this stage, it's perfectly fine. Okay. Yeah, so your ABC are 7 minus 24 and 425. They ask you to keep it in the form. Okay, so we have found the ABC values here. Yeah, keep this as an equation. Okay, so is this okay? Okay, so let's move on to question number 7. So they say here in this question, you must show all stages of your working. Solutions relying entirely on calculator technology are not acceptable. Okay, so you have to show all steps of your working. Now the first one they say here, solve for x greater than minus 90 and less than plus 90 the equation 3 sine 2x minus 15 equal cos 2x minus 15. So when you see this, do you see that both of these sine and cos ratios have got the exact same angle? Do you see that? So if you want to work, now they say to give you answer 1 dp and it's 4 marks. So one thing that you could do here to make your life simple, if you can't see it immediately, okay, now you can, there is actually a very easy method, we can convert this into a tan. However, if you can't see that, you can say, okay, let's say let 2x minus 15 be equal to what? Let's say, let it be equal to theta. So we can do the, we can do a small substitution like this to make our life easier. So what happens here then? We get here 3 sine 2x minus 15 is theta equals cos 2x minus 15 is cos theta, right? Okay, so then let 2x minus 15 be theta. So what do we get here? 3 sine theta equals cos theta. And then I get here, will divide. Both sides will divide by cos. So in other words, we will bring the cos to the other side as a division, isn't it? Dividing both sides by cos theta, in other words, means that you bring the cos theta to the other side as a division, which gives you what? 3 sine over cos means tan. Sine over cos means tan. Cos divided by cos is 1. Okay, so then when we make tan theta the subject, I get tan theta equal 1 over 3. Okay, so now let's solve. Let's use all silver teacups, choose quadrants where tan is positive. Okay, so we get here tan theta equal 1 over 3. Now choose quadrants where tan is positive. So what are the quadrants where tan is positive? All silver teacups. What are the quadrants where tan is positive? All and tan, right? All and tan. So these are the two quadrants. By the way, before you go take angles, it's better that you fix your range. How do you fix your range? Now you know your theta range is from where to where? Not theta range. They've given you the x range is from minus 90 to plus 90. So how do we get the theta range? Theta range is 2x minus 15. Basically, you multiply the entire range with 2 and subtract with 15. So multiply minus 90 with 2 and subtract 15 minus 90 into 2 minus 15. How much is it? Minus 195. Is that correct? Can you check on this quickly? And then this becomes 2x minus 15. The next one, 90 times 2. Multiply with 2 and subtract 15. What do we get? 90 times 2. I mean, you have to fix the range using this 165. Is that clear? So then 2x minus 15 is your theta, which means what? Theta range is between minus 195 to 165. Okay, so this is the range that you need to solve for theta. So solve for theta within this range and go rounds. Are you with me? Okay, so what's the first? Can you all get me the acute angle for tan inverse 1 over 3? It's supposed to be in degree mode. Can make sure your cal is in degree mode, okay? Check the mode of the calculator. Right now, my cal is in radian mode. So I need to shift it to degree mode. Okay, and then let's type tan inverse. Tan inverse 1 over 3. What do I get? 18.43. Now they want my answer, final answer to 1 dp, right? So let's take it to at least 4 dp, 3 dp's. 18.435. Let's get the first answer. What's the first answer for theta? 18.435. Can I jump this 180 degree and go to the other one? 180 plus 18.435? No, I can't go there, right? Because we are, the range allows us to go maximum of only 165. Therefore, I should go to the other side, because the other side it tells me that I have a negative range. Can you see? I have a negative range minus 195. Can I know how much this angle is? Should be 180. 180 minus 18.435. So it's a negative. How much is it? I gave a negative sign outside the bracket. Why did I give a negative sign? Because we come clockwise below the x-axis. Therefore, your angle must be negative. How much is it? Quickly. Huh, 180 minus 18.435. So I get 161.565 with the negative sign. Minus 161.565. Is this the final answer? No. The thing is, they've told us to get the answer to 1 dp for home. Solving, and you're supposed to find x. I found theta. So how do I find the x value? So theta is 2x minus 15, right? So how do I find the x value? So how do I find the x value? We need to make x a subject. Theta is 2x minus 15. To make x a subject, you take 15 to the other side as a plus and divide by 2. So both these answers, you will add 15 and divide by 2. Are you with me? 18.435. We add 15 and we divide by 2. And the other answer minus 161.565. We add 15 and divide by 2. Now this is the final answer. Take this to 1 dp. If this answer correct to 1 decimal place. Can I know the answer now? First this answer, positive answer. 18.435 plus 15 divided by 2. 16.7. And the other one? Minus 73.3. Is this clear? Check on the answers. Check on the accuracy. Roman number 2. They say for solve for theta between 0 to 2 pi. Now this time you can see here your theta is in what? It's in radians. Can you see? Theta is in radian. Now this time your sum, the answers must be in radian mode. They said here to solve 4 sine square theta plus 8 cos theta equals 3. So how do we solve this? These kinds of equations. So this is this is quite a, when you see sine square and when you see cos here, we know we can't solve it when you have two different types of trigonometric functions. So I need to convert it to one type. So what's the rule that we use to convert here? Either the whole equation must be in sine or the whole equation must be completely in cos. So what should I do to convert this into one type? So what's one of the main identities we use in this lesson? There is a main identity that we go in this lesson. What is it? Sine square theta plus cos square theta equals 1. So then I can use that to replace the sine square theta. Who is sine square theta? 1 minus cos square theta. Sine square theta is 1 minus cos square theta. So I get here 4 times sine square theta is 1 minus cos square theta plus 8 cos theta equals to 3. And then let's open the bracket. 4 into 1 is 4. 4 into minus 4 cos square theta is minus 4 cos square theta plus 8 cos theta. What do you see that we form here? I'm forming a quadratic equation. A quadratic equation in what? I get a quadratic equation in cos. So there's a cos square and there's a cos. Take everything. Should I take everything to the other side? And let's make it a positive cos square x. Cos square theta. So I get here 0. Shall I rearrange and write? Minus 4 cos square goes as plus 4 cos square theta. Plus 8 cos theta goes as minus 8 cos theta. The plus 4 goes as minus 4. 3 minus 4 means minus 1. Okay, so now this is a quadratic equation in cos. Can I know the factor? Does it factorize well or should I go for the formula? We'll go for the formula. Cos theta equals minus b plus or minus square root b square minus 4ac divided by 2. Make sure you show your methods. You need to show your methods when you solve quadratic equations, okay? Otherwise, you will not get the marks if you use the calculator. They have told very clearly solutions relying on calculator technology are not acceptable. So basically, it's a quadratic equation. Just don't give ABC in the cal and get the answer. Make sure You substitute the ABC value into the quadratic formula and actually get the answer. Okay, so what do I get here? Substitute the values. Input the value here. So minus 8, B. So B is minus 8, right? A is 4 here. B is minus 8 here. C is minus 1, right? So I get here minus 8 plus or minus square root. B square is minus 8 square. 4 into A is 4 into C is minus 1. Divide by 2 times A is 4. Do you agree with me? So I end up getting here 8 plus or minus square root. Can I know the value inside the root? What is the value inside the root? How much? 80. Divide by 2 times 4 is 8. Can I know the two answers for cos theta? So we want the answer here, 3 significant figures. So can I have the middle answers to a little bit more significance? 2 plus root 5 over 2. And the other answer? 2 minus root 5 over 2, right? These should be the two answers. Okay. So now let's get the cos inverse. So let me take it down over here. Cos theta is 2 plus root 5 over 2. Can I have the figure here? What is the cos theta value here? Can I have a few more values? Because I want to see whether it's positive or negative, basically. So 2 plus root 5 over 2 is 1.689106. Okay, now let's say cos inverse, it's a positive figure. I need the positive or negative here because based on the positive negative, that's how I choose quadrants. Okay, and anyway, when you see 1 point for a cos theta graph, you need to realize something. What? You know, the cos graph never reaches beyond 1. The maximum cos theta graph can reach is actually 1. So if you type cos inverse of this particular value, you should definitely get what? You would definitely get math error, right? Am I correct? If you type cos inverse 1.60 or cos inverse 2 plus root 5 over 2, you would get cos inverse of 2 plus root 5 over 2. Okay, 2 plus root 5 over 2 is, how much is the value? Not 1.68. It's 2.11. 2.1180. Okay, so you guys told me the cos inverse answer. Now I want the 2 plus root 5 over 2. 2 plus root 5 over 2 is 2.118033, right? Okay, so then this answer is bigger than 1, which means what? Cos inverse of 2.11 is definitely what? Math error, which means what? There are no solutions. We don't have solutions because the cos graph never reaches for a value like this. The maximum your cos graph reaches is 1. Go for the other solution. The other solution is cos theta equals 2 minus root 5 over 2. Can I know the value of 2 minus root 5 over 2? Don't take the cos inverse first. First, take the value of 2 minus root 5 over 2 because I asked like that for the earlier question as well. 2 minus minus 0.118033. Okay, so basically, let's say 3, 4 here. Okay, what kind of an answer do I have? The cos theta value here is a negative value, which means what? When I go for quadrants, I must choose quadrants where cos is. I must choose quadrants where cos is what? Negative. So what are the quadrants where cos is negative? Sine and tan. Sine and tan. Can I have cos inverse of, don't, when you're typing getting the acute angle, you don't give the negative. Just type cos inverse 0.118034 when your cal should be in what mode? Here the question is supposed to be in radians. Do you see 0 to 2 pi? So the cal must be in the radian mode. So what do we get here? Cos inverse. So cos inverse, the cal must be in the radian mode. So angle input radian mode, cos inverse minus, no, don't give the minus, give 0.118034. Basically, the minus mark is only used to identify the quadrant. Okay, so the cos inverse 0.118034 is 1.45248. Basically, they want the answer to 3SF. So we'll take it 1.45. Okay, so remember that what you are getting here is what? You are getting the acute angle between for the quadrants where cos is negative. Remember, you are not getting the answer here. This is not the final answer, but I getting the cal here as 1.4525. Let's say it's 1.4525. This is not a final answer. Okay, it's just the I mean these two acute angles, the two with the two quadrants where cos is negative. 1.4585. So we'll mark that. And now let's get the real answer. How do I get the real answer? Range is from 0 to pi, 0 to 2 pi. So what do we do here? The first answer is for theta, pi minus 1.4585. Do you see? Because from 180, you should subtract this angle to get this particular answer. The other one, pi plus 1.4585. Are you with me? How much do I get here? Pi minus 1.4585. 1.689, correct to 3SF, 1.69. And the other answer, 4.59. So these are the two answers I can get within the range 0 to 2 pi. Okay. This is clear. Question number 8. A metal post is repeatedly hit in order to drive it into the ground. Given that on the first hit, the post is driven 100 millimeter into the ground. On the second hit, the post is driven an additional 98 millimeter into the ground. On the third hit, the post is driven an additional 96 millimeters into the ground. The additional distance of the post travels on each subsequent hit form an arithmetic sequence. Do you understand what's going on here? On the first hit, you go 100 millimeters. Second hit, you go 98 millimeters. I mean, that means a further 98 because you're already 100 millimeters in. Second time you hit, it goes another 98. The third time you hit, it goes another 96. So basically, by the time you end up with the third hit, you have traveled this total distance. Do you realize? So they say this this particular this particular order is actually an arithmetic sequence. You can see it's an arithmetic sequence with common difference is what? 100, 98, 96. You can see it reduces by 2. Common difference is -2. Okay, so they are asking you, this is the term 1. Term 1, this is the amount it goes in the first hit. Term 2 is the amount that is driven in by the second hit. Term 3, the amount that is driven in by the third hit. So they want, they say show that the post is driven an additional 62 millimeter into the ground with the 20th hit. Basically, what do they want you to find? They want you to find the T20. Can't you find T20? Term 20 is, so what's the term equation? Arithmetic term equation is? Arithmetic term equation is what? Tn equal a plus n minus 1d, right? So term 20 is what? A means the first term, 100 plus n is how much? N is 20 here, right? 20 minus 1 into common difference is what, Dada? I told you just now a moment ago. Common difference is what? 100, 98, 96 means common difference is -2 because you're subtracting by 2. This is okay. So I get here 100. 20 minus 1 is 19. 19 times -2 is how much? 19 times -2 is how much? $38. How much is the T20 answer? 62 millimeters. So this is the additional distance it's driven into the ground in the 20th hit. Are you with me? Okay, then part B, they are asking you find the total distance the post is that the post has been driven into the ground after 20 hits. So what's the total distance the post has gone into the ground? What should you do? You know, with each hit you go, the additional distance you travel into the ground is given, right? So if you want to find the total distance the post has gone into the ground, what should we do? We should take the sum of the 20 terms. So let's get the sum. So there are two equations, n over 2 times 2a plus n minus 1d, or there's another equation. Sum equals what? N over 2 a plus l. So we can go with any one of these. So use one of these two equations. So shall I use the last term equation? When divided by 2, A is 100. What's the last term? So last term, the 20th term I found, right? Which is 62. And I know the answer here. How much is the answer? 10 times 100 plus 62 is 162. So I get here 10 times 162 is 1620 meters. Is this clear? Not meters, millimeters. Be careful of the unit. Because so basically by the time you do the 20th hit, the post has gone into the ground a distance of 1620 millimeters. Okay. We now look at the part C. So this is where it gets interesting. So they say here, given that for each subsequent hit after the 20th hit. Okay, so after the 20th hit, the additional distance the post travels forms a geometric sequence with common ratio R. Okay, let's go again. Now the 20th hit, how much did it travel? So this was 100, 98, 96. It went on until what was the 20th hit? For the 20th hit, it went 62 millimeters in, right? Okay, so this is the term 1, term 2. This is from the arithmetic. This is term 3, the term 20. Now, what happens after the 20th term? What happens after the 20th term? They say the additional distance the post travels forms a geometric sequence with common ratio R. Okay. Okay, so they are asking us to find the value of R correct to 3 dB. Now look at this. Now they say here after the 20th term, the 21st term onwards, what does it follow? It follows a what sequence? A geometric sequence with common ratio R. So they are asking you that says that it follows a geometric sequence with common ratio R, which means what? How do I get the 21st term? Now you know. Now you saw when it was arithmetic, I subtracted 2 from the previous term and I got the next term. I mean, we take the common difference and add it with the previous term. When you add the common difference to the previous term, you get the next term. That's how arithmetic works. In geometric, how does it work? We have a common ratio called R, right? We take the R and what do we do it with the previous term? We multiply. The common ratio is multiplied with the previous term. Do you remember? First term is A, second term is AR. Next term is AR square. That means we multiply the previous term with the common ratio. Isn't it? So then after 62, the next term is a geometric with common ratio R, which means what's the 21st term? 62R. This is the 21st term. What's the 22nd term? 62R square, because you have to keep multiplying by R to get the next term. That's how geometric works. So you realize, so this is the term 22. And they say term 22 what? On the 22nd hit, the post is driven an additional 60 millimeters. So basically this is the term, right? The additional 60, because all of these are the term values. So the 60 millimeter is your term 22. Are you with me? So 60 millimeter is the 62R square. So how much is R square? R square is 60 over 62, which means R equals to root 60 over 62. Can I know how much is R? They want the value of R to 3 dP. How much is it? How much is it? 0.984 to 3 dP. Is that clear? Okay, then they say after a total of n hits, the post will have been driven more than 3 meters into the ground. Find, showing all the steps in your working, the smallest possible value of n. Okay, how do we find this? How do we find this? Now, first of all, you know, now the first, I think you can see in the first 20 hits, we had a what sequence? We had an arithmetic. So previously, until this point, it's arithmetic. After this point, it is geometric. So from the arithmetic sequence, how much of a distance did we go inside the ground? By using the arithmetic sequence, we have gone 1620 millimeters onto the ground. Okay, so then, and then they are saying now here 3 meters. Can you remember 3 meters to millimeters? 3 meters is 300 centimeters. Centimeters to millimeters multiplied by 10. So 3 meter in other words is what? 3,000 millimeters. Are you with me? 3 meter is 3,000 millimeters. Okay, so now what I need to do here is from the arithmetic sequence, you realize that you have gone 1,620 millimeters onto the ground. Then from the from the arithmetic, we have gone 1,620 millimeters onto the ground, inside the ground. Then how much more am I supposed to travel from the geometric? Okay, so then yeah, sorry, this should be 300 millimeters, right? 300 millimeters. Okay, so then I was asking you that from the arithmetic sequence, we travel 1,620, and how much more of a distance is remaining to travel from the geometric, right? But the thing in here is they say here after the total of n hits, the force will have been driven what? Exactly 3,000 millimeters? Is that what they say? No, they say here what? The force has been driven more than 3,000 millimeters onto the ground. So then we'll write like this. We know the first 20 terms give us a arithmetic sequence, right? So 1,620 millimeters from the arithmetic sequence plus what? Plus I need to get the sum of my geometric sequence, because you do need to realize that I have a geometric sequence after the 20th term. I'm marking from green color. This T1, T2, what I mark from green color is the geometric sequence. Okay. So if I add the, now I have 1,620 from the arithmetic, plus if I add the sum of my geometric sequence terms, the answer should be what? They say here very clearly, it should be more than 3,000. So this is what you need to write. The sum of the two sequences must be more than 3,000. So how do I get the sum of the geometric, sequence? What do we do? Sum of a geometric sequence equation is what? A times 1 minus r to the power n over 1 minus r. If r is less than 1, I think you can see here our r value is less than 1, right? Isn't it? Our r value is less than 1. So shall we use it here? Shall I make sum of geometric the subject? So sum of geometric, can I know the value here? 3,000 minus 1,620 is how much? 1,380. So let's use the sum of geometric sequences. So remember I'm taking the sum of geometric from the 21st term, but I'm considering the 21st term as the first term here. And let's see how many terms in the geometric sequence we need to consider. So what's the sum of geometric? A 1 minus r to the power n over 1 minus r. Remember here, n means what? N is the number of terms that I'm taking from the, n is the number of terms that I'm considering from the what sequence? From the geometric sequence. Okay, so n is the number of terms I'm taking from only from the geometric sequence. Basically, the terms I'm marking in this green color. Okay, so these are the terms I'm taking from the geometric. Can you all make n the subject? Can you all make n the subject? So how do we make n the subject? A is, what's the first term in the geometric sequence? Who is the first term in our geometric sequence? Who is the first term? Term 1 is 62r. 62r. Substitute 62r. 1 minus r to the power n over 1 minus r. Greater than 1,380. Shall we input the r value? Input the r value. So we will need to get a decimal, right? Smallest possible value of n. Okay, let's input the r value. 62 times r. Can I have a little bit more extra significance r value? The more we use for r, the better. Can I have a better r value? 0.98. 9837. Okay. Okay, 0.983738. Shall we use that? 62 prime 0.983738 into 1 minus 0.983738 to the power n over 1 minus r. Greater than 1380. Can you all quickly type this part in the calc? Let's try take it all to the other side or else. 1 minus 0.983738 to the power n greater than, let's take all these numbers to the other side, 1380 multiplied by 1 minus 0.983738 over 62 times 0.983738. How can I know this value here? How much is the value here? So how much do we get here? The power n greater than how much is it? 0. So I get the answer when I type in the calc 0.367944153, right? So what do we do now to make, I want to make n the subject. Basically, you can see I have n as a power of this guy. So I'll take this number to the other side as a plus and take this to the other side as a minus. So directly give it in the calc 1 minus this answer. 1 minus answer when you give, you get here. Okay, so you get here 1 minus this answer. You type it in the calc and that gives you 0.632055 or 20558. Yeah, that's enough. Greater than 0.983738 to the power n. Do you see what I've done here? So I've taken the minus 0.98 power n to the other side and I've taken this to this side. I subtracted the two and I've written these two answers. Now, how do I make n the subject? Put log to both the sides. Take the logarithm of both the sides. And then what happens? Log 0.6320558. The n comes in front, log 0.983738. And what happens? Now do you remember now I need to bring the logarithm to the other side. I have to make n the subject. So when I make n the subject, this log 0.9837, this comes down as a division, right? So what happens? When you bring a logarithm of, if you take a 0 point logarithm to the other side, do you remember I have told you about this? A logarithm of a 0 point number is what? And the thing is, the most important thing is we have an inequality here. Are you aware that an inequality mark is sensitive to division by a negative sign or multiplication with a negative? If you take the division, the sign, you'll get the, you have to flip the sign, right? So you can say here, see here, if I take the logarithm of, okay, just log means we take log base 10. The logarithm of 0.983738. What do you see here? It's a what answer? It's a negative answer. So basically, I am taking now here, I have log 0.6320558. Okay, that's also a negative answer, but that's fine. The important thing is, the crucial thing here is that you bring this logarithm to the other side as a what? You bring it to the other side as a division. So what does that, how does that affect the inequality? The inequality mark must flip now. The greater than sign becomes less than, you get n here. So it's extremely important that you flip the inequality sign because you divide by a negative. So now type these two values in the calc and I know how much is n. N is greater than 27.9816. So what's the first n value that I need to take here? N greater than 27.9816. They want the exact value, the hit. So n greater than 27.9816 means the first n value we need to take here is 28, which means what? I take 28 terms from the geometric sequence. I take 28 terms from this geometric sequence. In addition, before that, there were another how many more hits? 20, because there are now 28 hits from the geometric. Previously, there were 20 hits from the arithmetic. Altogether, how many hits? So total number of hits, total hits of capital N is 20 plus the 28. 20 from arithmetic, 28 from geometric. Total number of hits is 48. Is this clear? Okay, so we'll move on to question number 9. Figure 2 shows the curve C with equation y equal x minus x square. The line L with equation y equal mx. Okay, can you see? X minus x square is the quadratic maximum curve. And the line y equal mx is a straight line where m is a constant and m is between 0 and 1. Okay, they have told you m value is supposed to be between 0 and 1. The curve, the line and the curve intersect at the origin O and at the point P. Find in terms of m the coordinates of P. Okay, so they're asking you to find in terms of m the coordinates of P. How do we do that? How do we do that? We solve the two equations simultaneously, right? To find the coordinates of P, because that's the place where the two graphs intersect. Shall we solve it simultaneously? So y equal x minus x square and the other equation y equal mx. Solve them simultaneously. So I will make the two y values equal. X minus x square is equal to mx. Do you agree? We need to make them equal. And then take everything to one side. So I'll get the positive x square here. X square plus mx minus x. Do you agree with what I did here? I just took the minus x square to the other side as plus x square and this plus x to the other side as minus x. The plus mx stayed here. And then what do? I think you can see we can, x is a common term to everyone, right? Shall we take x out? So when you take x out, I get here x plus mx. When you take out x, I get m. From minus x when I take x out. Basically, when you remove x, it's 1, right? Taking x out means you are dividing by x. Do you agree with me? Okay, so now make each factor equal to 0. Okay, so let's make each factor equal to 0. X equals 0 or x plus m minus 1 equals 0. What do we get here? X equals 0 or x equals minus m plus 1. Do you agree? X equals minus, oh, we can say 1 minus m. Okay, so this is basically, I think you can see x equals 0 should be the origin. You can see there are two places where the graphs meet. When you solve the two equations simultaneously, you find the place where the curves intersect. So basically at O, that should be definitely the x equals 0 point. Okay, anyway, I'm interested in finding the coordinates of P. So they say here, find in terms of M the coordinates. Coordinates means not just the x, but you also have to find y. Shall we find the y value? So use the equation, the x value on any one of these two. So I prefer to always go with the linear equation, okay, because it's less amount of work. Y equals mx. Let's substitute y equal m times x is minus m plus 1. Do you agree with me? So this is it. So the coordinates of P, you can write the coordinates of P are minus m plus 1, comma m times minus m plus 1. Do you agree with me? This is the answer for part A. You can open the bracket and expand and keep your answer. It's perfectly fine, okay? Okay, moving on to part B. The region R1 shown shaded in figure 2 is bounded by C and L. Okay, so you can see region R1 that they have shown shaded here. So they are saying it's bounded by the curve and the line L. Show that the area of R1 is 1 minus m holding to the power 3 divided by 6. Okay. How do we find the region, the area of region R1? First thing is you need to find the boundaries that are around region R1. So starting boundary is 0 and the ending boundary here is at this point P, right? Because that's where the boundary ends. Are you with me? The ending boundary here, the x value is, I think we found it's minus m plus 1. Shall I put it as 1 minus m? Minus m plus 1 is 1 minus m, right? And here they say as m value is between 0 and 1, right? So 1 minus m is a positive figure. Do you agree with me? Because m is a figure between 0 and 1, 1 minus m is a positive figure, this value. Okay, minus m plus 1 in other words is 1 minus m. Okay, right. So now what we're supposed to do is I want to find the area of this region R1. However, when you integrate, when you integrate from 0 to this 1 minus m point, now we are going to integrate which curve? Obviously, we will be integrating the quadratic curve, right? From here to here. So when I integrate the quadratic curve from 0 to 1 minus m, am I only going to get the R1 area? Am I only going to get the R1 area? No, you get the area between the curve, the two boundaries, the two x boundaries and the x-axis. You get the area completely, underneath the curve and trapped between the x-axis. So basically, you get this area. Do you see the area I'm highlighting? This is the full area that you are getting when you integrate from 0 to 1 minus m. So you can see region R1, I only need this top part. I don't need this bottom part of the shaded area. So how do we find the, what we need to do is first we integrate from 0 to P, 0 to 1 minus m. And then we get the full area. And what do? We can Afterwards, remove this triangle. Do you see a right angle triangle here? Or you could, if you want, you could say you get the area underneath the line from 0 to 1 minus n. You get the area underneath the line from 0 to 1 minus n, and then you subtract the two areas. Okay? So shall we try that? Okay, first we'll find the area completely underneath the curve. So area underneath the curve P. Okay, so area, part B. So how does it work? Or there's another way of doing it, right? In your book, we also learned that there's the other technique where you take the top curve and subtract from the bottom curve. Do you remember that? There is also an equation where you do integration y1 minus y2, where you subtract the two curves initially itself, and then basically what you do here is y1 is representing the top curve, y2 represents the bottom curve, this one, the straight line. So when you integrate, from the top one, if you subtract the bottom one, you get the area in between. Do you remember this theory? Do you remember this theory? So this is also something we could use. Otherwise, you could do it individually, where you get the area underneath the green color curve, then you get the area underneath the red color curve, and you subtract. That's individually also you can do. Or you can directly do. I think this is the direct method is a lot easier because it will save you a lot of time. Shall we do the direct method? Okay, because you can see we need the area trapped in between these two. So let me get that. So y1 minus y2, integration of y1 is the x minus x square, that's the top one. From that, we should subtract the bottom one. The bottom line is y equal mx. From the top one, subtract the bottom one. With respect to x, and your limits were from 0 to 1 minus m, right? The x limits were from 0 to 1 minus m. Is that clear? Okay, then let's get the answer. Integration from 0 to 1 minus m. When we integrate, shall I first open the bracket? X minus x square minus mx. Okay, let's integrate. Integration of x is x square over 2. Integration of x square is x cube over 3 minus mx. Integration is m x square over 2. From 0 to 1 minus m. Shall we substitute? First, we'll replace all the x values with 1 minus m. So 1 minus m square over 2 minus 1 minus m cube over 3 minus m times 1 minus m square over 2. So this is the first one, first limit. And then subtract the second limit. You must replace all your x values with the 0. What happens? So when all the x values are replaced by 0, you can see everything becomes 0 here. So there's nothing we can take from there. Okay. So now let's simplify, and I need to get that the area of R1 is this. We need to get this, show that. Okay. Okay, how do we get this, show that? First thing is, shall we take the common things out? What are the common things here? For example, you can see 1 minus m to the power 2 is common. Do you agree? For all these three terms, 1 minus m square is common. Shall I take it out? 1 minus m to the power 2 is common. Let's write what's remaining in. When 1 minus m square goes out, what's remaining here? Simply half. Minus here, when 1 minus m square goes out from 1 minus m cube, what happens? You have a 1 minus m to the power 1 remaining when square goes out, and then over 3. Minus here m times 1 minus m square goes out, so just m remains over 2. Do you agree with me? Well, then shall we take the common denominator here? What do you think is the common denominator that works for 2 and 3? 6. So we'll multiply here. 2 times 3 is 6. Here 3 times 2 is 6. Here 2 times 3 is 6. Do you agree? So I get here 3 over 6 minus 2 times 1 minus m over 6. Basically, shall I take it all over a common denominator? Common denominator is 6. So here 3 times 1 is 3 minus 2 into 1 minus m minus 3 into m is 3m. 1 minus m square. Actually, the square should be outside the bracket, right? The square is supposed to be 1 minus m outside the bracket. Open the bracket here. 3 minus 2 into 1 is 2. Minus 2 into minus m is plus 2m minus 3m. over 6. 1 minus m to the power 2. What's happening here? When you simplify, 3 minus 2 is 1 plus 2m minus 3m is minus m over 6. Do you see what you get here? So here you get 1 minus m square multiplying with another 1 minus m. What happens? It's 1 minus m to the power 3 and then denominator is 6 because this is over 1. Denominator is 6. Do you agree with me? Is this clear? Okay, moving on to part C. They say the region R2, also shown shaded in figure 2, is bounded by the curve, the x-axis and the line L. So you can see the region R2 is shown shaded here, right? And they say here, given that the area of R1 is equal to the area of R2. The R1 area is equal to, if it is equal to the area of R2, they ask you to find the exact value of M. Okay, so you know what you should do here. Okay, so basically region 1 area, we just found a few, we just found it in the previous part, region 1 area. Okay, what we'll do is this. We'll first get the area under this entire curve. Shall we? We'll get the area under this entire curve, the quadratic maximum curve, the full area above the x-axis. How do we get that? So your equation is y equal x minus x square. First thing I should do is I need to find the place where the graph intersects the x-axis because that's the place where the limit is ending. Shall we find that? Y equal x minus x square. When you cut x-axis, y is 0. 0 equal x minus x square. Taking x out, 1 minus x. Do you see what we get here? X equals 0 or 1 minus x is 0. X equals 0 or 1 minus x equals 0 is x equals 1. Do you agree with me? I'll write it the other way. X equals 1. So basically this cutting point here is 1. Are you with me? Okay, shall we integrate the whole curve x minus x square? When you integrate from 0 to 1, you will get this full area. You will get this complete area. Are you with me? I will get the complete area. Let's get the complete area. Total area. Basically what I'm getting here is R1 plus R2. Do you agree with me? Because when we integrate from 0 to 1, I get the R1 plus R2, like the full addition. So this is equal to integration of x minus x square with respect to x from 0 to 1. So when we integrate this, we get here x integration is x square over 2, x square integration is x cube over 3. The limits are from 0 to 1. Are you with me? Replacing x with 1, 1 square over 2 minus 1 cube is 1 over 3. Minus replacing the x with 0. What do we get here? 1 over 2 minus 1 over 3 is 1 over 6. Okay, so this is the area of the full part. The area of R1 plus the area of R2 is 1 over 6. Do you agree with me? However, they do tell you what? They tell you in here the area of R1 is equal to area of R2. Area R1 is equal to area R2. So both of these areas must be equal to 1 minus m cube over 6. Because they do say here the area of R1 is 1 minus m whole thing to the power 3 over 6, right? So if area of R1 is equal to area of R2, then it's this. Then we can see here, we know area of R1 plus area of R2 is what we got as 1 over 6, right? Do you agree with me? Area of R1 plus R2 is what we got. The total area is what we got as 1 over 6. So do we know the individual area of R1 and R2? Yes, we just know here. They have told us area of R1 we found individually and they also tell us it's equal to area of R2. So area of R1 is 1 minus m whole thing to the power 3 over 6. Again, R2 is also 1 minus m whole thing to the power 3 over 6 equals 1 over 6. Do you agree with me? So now we can add everything is in the common denominator. I can multiply everyone with 6. Shall I multiply the whole equation by 6? It's common. 6 is common to everyone. So I get here 1 minus m cube plus 1 minus m cube equals 1. So add this 1 minus m cube plus 1 minus m cube is 2 times 1 minus m cube equals 1. So 1 minus m whole thing to the power 3 equals 1 over 2. Are you okay with that? I added these two terms. Okay, I can add these are two like terms. So I added them. I got two of them. Then I took the 2 to the other side because before you remove the cube root, you must remove the outside number outside the bracket. Now, remove the cube root. How do you remove a cube root? Cube root removes the other side as a power of 1 over the cube. Sorry. The cube removes the other side as a cube root. The power 3 is the cube. It removes the other side as a cube root. Power 1 over 3 is the cube root. So then we get here, when we subject m, I'll take the m over here and I'll take this over here. So we get 1 minus half to the power 1 over 3 equals m. Do you agree with me? So this is the exact answer. I think they wanted the exact answer, right? Find the exact value of m. So this is the exact value of m. Okay, so you can say 1 minus cube root half. So any of these formats are okay, even this or even this, or another person could separate the cube root as 1 to the power 1 over 3, 2 to the power 1 over 3, and they could write 1 minus 1 to the power 1 over 3 is 1, 2 to the power 1 over 3 is cube root 2. They could leave the answer like this also. So all of these formats are correct. Okay, you could keep your answer any equivalent form is fine. Okay, so this is the value of m. Are you clear? Okay, moving on to question number 10. Prove by count example that the statement if p is a prime number, then 2p plus 1 is also a prime number is not true. So prove by a count example means what? You have to input values for p and show that if p is, you have to input p is a prime number. Basically, you need to use prime numbers to this value 2p plus 1 and show that the statement what? The 2p plus 1 is also a prime is wrong. So that's what we mean by prove by a count example. So you have to input values and do. Okay, so what are the prime numbers we have? The first prime number, we can start with 2. If you start with 2, what do we get for 2p plus 1? What do we get for 2p plus 1? When p equals 2, 2p plus 1 becomes 2 times 2 is 4, 4 plus 1, 5. No, that doesn't work because we need to show it's not true. Right? Then when p equals 3, how much is 2p plus 1? 2 times 3 is 6, 6 plus 1, 7. It's still a prime. The next prime number we can use after 3. Who is the next prime number? 5. When p is 5, what do we get? 2p plus 5. 2 times 5 is 10 plus 1, 11. Still a prime number. Okay, keep on. You need to keep on going until you prove the statement is wrong. So prove by a count example. What's the next one? 7. So what is it? 2 times 7 plus 1 is 14 plus 1, 15. Now you can see 15 is not a prime number. Therefore, statement is not true. You could only show the working for p equals 7 actually. You don't need to show any of the p equal 2, 3, 5 working. It does not need to be seen because it's just how many marks? 1 mark. So they only need to see the working relevant for p equals 7 and you show 2p plus 1 is 15 is more than enough and just give a statement. Okay, none of the other statements are required. You can do it from your head and see whether you get a prime or not. For p equal 2, 3, 5, you input the values in your head and you see, okay, there is a prime number, so they don't work. I have to go with p equals 7. Okay, so these workings do not get marked because you need to see it's just 1 mark. Anyway, even if you write, it doesn't hurt. Okay, so therefore, what do we write? Therefore, the statement is not true. Okay, do you see how it's done? This was the answer for Roman number 1. Roman number 2. Use proof by exhaustion to prove that if n is an integer, then 5n square plus n plus 12 is always even. Okay, what are they asking you to prove? They ask you to prove if n is an integer. So integer means like all the whole numbers, right? Then if n is an integer, you need to show that 5n square plus n plus 12 is always even. Okay, now when it comes to even, an even number is always what? How do we identify even numbers? How do we identify even numbers? They come with a multiple of, an even number is always a multiple of 2. That's how you identify it's even. Okay, but now how do we prove that this particular statement 5n square plus n plus 12 is a multiple of 2? You can see basically there's no way to take a 2 out just like that. So what we do here is when we take the integers, we can take our integers into two sets of integers. Okay, so how can we break the integers? What are the two sets we should break this into? Break your integers into the two sets of integers, the basic way we break integers. What are the two basic sets we break? Your integers can be broken as, can be broken as what? As even integers and odd integers. So break it like that and then show for the odd set is also becoming even for all the n values and show that the even set also becomes even for all the n values. Okay, that's how we do this proof, and they say proof by exhaustion. That's what you should do here, because proof by exhaustion does not mean that you will input all the n values. You can't. There's no n to the integer, right? You cannot put in manually input 1, 2, 3. That doesn't work because there's no n to the set of numbers. Okay, so what we'll do here is we will consider this under two cases. We'll break the integers into two sets when n is even and when n is odd. Okay, so when n is even, what happens? When n is even, so let's consider n equals to what? 2k. Okay, so let's take when n is 2k. Even means a multiple of 2, right? Shall we replace the n with 2k here? Replace n with 2k. Yeah, we'll replace n with 2k. So what do we get here? So we get here 5 times n square, 2k square, plus n is 2k, plus 12. Can you all simplify? What do we get here? 5 into 2k square is 4k, right? 4k square. Plus 2k plus 12. Mainly what you need to see is whether we can take a what out. Whether we can take a 2 out, because we need to show it even. Okay, so can I take a 2 out here from everyone? Yes, right? So when I take a 2 out, I get here 5 times 2. 5 times 2k square, which is 10. Because here 5 times 4, 20. When I take a 2 out, it's 10k square. Here 2k, I take a 2 out, it's k. 12, I take a 2 out, it becomes 6. Do you agree with me? This is clear? So what do you say then here? Okay, so this is a multiple of 2. A multiple of 2. Therefore, the result is even. Are we done yet? Are we done yet? Because we have to prove for all the integers. All the integers doesn't mean only the even integers. We have to also do this for the. We have to also do this for the what? Odd integers. When n is odd. So what is the format we use for odd integers? N equals to 2k plus 1, isn't it? That's the format we use for odd. Even is 2k, odd is 2k plus 1, or 2k minus 1 is also okay. So basically we go with 2k plus 1. Let's replace 5 times n square. So 2k plus 1 square. Replace every n value with 2k plus 1. 5 times n square plus, this is just 10, yeah, plus just 10. N is 2k plus 1. Plus 12. 5n square plus n plus 12. Let's open the bracket 5 times. 2k plus 1 square is 2k plus 1 into 2k plus 1. Do you see I wrote the bracket twice? Plus 2k plus 1. The other one is plus 12. So opening this, what do we get here? 2k into 2k is 4k square. 2k into 1 is 2k. Plus 1 into 2k is 2k. Plus 1 into 1 is 1. Open the bracket here, 2k plus 1 plus 12. So expanding the bracket here, 5 times 4 is 20k square. Shall I add these two together? 2k plus 2k is 4k. 4k into 5 is 20k immediately. And then plus 1 into 5 is 5. Okay, I added these two here and then I multiplied it with 5. The last part is 2k plus 1 plus 12. Shall we add everything? So I get here 20k square. Plus 20k plus 2k is plus 22k. Can you all add the values here? 5 plus 1 plus 12. How much is it? 18. So main thing is, can we take a 2 out? Yes. 10k square plus 11k plus 9. This is again what? A multiple of 2. Therefore, the result is even. Then what do we say? You can say the result is even for what? The result is even when n is even. The result is even when n is even or odd. Therefore, what can we say? Therefore, give the conclusion. Therefore, what do they say here? Therefore 5n square plus n plus 12 is always even. Is even. Or okay, so again I'll say here the result is even when n is even or odd. Therefore 5n square plus n plus 12 is even for all integers n. Okay, just give the conclusion here. Okay, is this clear? Okay, so that's it. This is the end of the January 2022 P2 paper.